SAS demonstration macro demo 1. This program was originally written by a former programmer who used to work at the College of Public Health named Fred Ulrich. And you might notice that the comments that he put in this program are a little bit funnier than the comments that you've seen in the programs that I've done SAS demonstrations for previously. We are going to start by creating a data set called work. And for each observation, we're reading in the subject's initial, their height, their weight, their gender, and the time point in which these values were recorded. And then we have a couple of statements here. He's created a variable called short, which is equal to yes if height is less than 170, else short equals n for no. And then he's created a variable called heavy. If weight is less than 80, then yes, else heavy equals n. And you see here we're using in-stream data, and he's used this at statement, so he repeatedly reads in observation after observation. And so the first thing we're going to do is just print out this data. So again, he's just made this data set work, and we're going to print it out, and then we're going to see how we can use macros to work with this data set. So here's a printout of the 68 observations, and included in the printout are the new variables that we created, short and heavy. And then the next thing that the program does is just generates a bunch of output. We're going to do proc means on height and weight. We're going to do frequencies on the categorical variables short and heavy. And lastly, we're going to do a t-test comparing height and weight between males and females. So again, we're just trying to generate some output. This is not so much for analysis purposes. So here's our output. Here is the information we have on the mean height and mean weight for the 68 subjects in the data set. Then we have the number who were classified as short and the number who were classified as not short based on that height cut point, and the number of subjects who were classified as heavy and not heavy. And here we have the results of our t-test for height, where we're comparing it between males and females, and it does not appear that there's a difference in height, because here the equality of variance shows that we cannot reject the null hypothesis that we have equal variance. So we see here our p-value is not significant, so height appears to be similar between males and females. And if we look at weight, again, the weight appears to be similar between males and females. So that was the output that was generated. Now let's say we wanted to use a macro variable to change conditions of the where statement. So we are going to start with the %let to create a macro variable called wait time, wait underscore time. And we're setting it equal to 3. So any time in any procedure following, when SAS sees this macro variable, it is going to substitute the value of 3 into that statement. So here we have proc means, and we have this statement where time equals ampersand wait underscore time. And so when SAS reads it, it's going to see the statement where time equals 3. Similarly, when it does a proc freq, we have this where statement. Again, it's going to substitute in where time equals 3. And then lastly, with our proc t-test, same thing. So any time that SAS sees this ampersand wait underscore time, it's going to substitute in the value of 3. And that's how this macro variable works. So let's run this code and just take a look quickly at the output. And so here again, all of the same analysis were done, except they were done when time equals 3. Let's say we went in here and changed this to a 1, then all of these same analyses would be done for when time equals 1. So this is a very fast way of making changes in these procedures without having to go into each procedure and change the value to 1 from the value of 3. All we do is make the change right in our %let statement. So imagine if you were doing many procedures and you wanted to select a certain analysis done based on a where statement. It could be very helpful if you had this macro variable to change conditions, and that will automatically be changed through your procedures. Another thing we can do with macro programming, we can actually define a macro that we can then call repetitively. So here we're creating a macro called count stuff. And what we want in our macro is contained within the lines %macro count stuff and %mend. And so what we're interested in is the proc means, the proc freq, and the proc t-test. So let's just run this code and see what happens. At this point, nothing happens. All we've done is just defined our macro. So if we go to our log, again, nothing happens. We just show that we've defined a macro here. SAS doesn't have any output about that. And then to call our macro, we just use the % followed by the name of the macro. So here we're saying, okay, data work temp, and we're bringing in that original data set work, and we're saying where time equals 1 or time equals 2. So we've redefined our data set work temp. We've actually taken some of the observations out of it because we're not looking at time equals 3 or time equals 4. And so if I ran this code, it's automatically going to generate all of these procedures, proc means, proc freq, and proc t-test, just by saying %count stuff. So if we run this, we see here that again, all those procedures were automatically run for us. Now if we redo our data step and we say data work temp where time equals 1 or time equals 2 and heavy equals n. So now we're selecting only observations from time equals 1 or time equals 2, and only those observations that were classified as having a weight not being heavy. And then we did %count stuff. Again, we would run all of these procedures automatically on this different data set. So if we highlighted this, again, we would get the output from the t-test procedure, from proc freq, and from proc means. Now let's, again, make this a little bit more complicated. We're going to define a macro that we can call repetitively, and we're going to add a macro parameter to specify variables. We want to make this macro more generalizable. So here we're calling our new macro count stuff 2, and in parentheses we're listing our macro parameter, and we're calling it vars. Now to indicate that you're dealing with a macro parameter inside your macro, you use the ampersand and then followed by the word for the macro parameter. So here we're doing just a proc means and a proc t-test, and we're indicating that we're using a macro parameter ampersand vars. So here's where we're defining our macro, and then in this example here we are going to run this new macro and we're going to substitute in the variables height and weight. So let's say we have lots of variables on our data set, lots of continuous variables. You could list any group of those continuous variables in parentheses, and they will be substituted into the macro at those points where ampersand vars are in the macro itself. The other thing I want to point out is why did I say only continuous variables, and that's because the procedures that we're doing are a proc means and a proc t-test. So again, if we ran this program, we are now going to see t-test results for height and weight, as well as mean results for height and weight for the selected group of subjects where time equals 1 or time equals 2. Now in this next example, we're going to make some data, and we're going to call our data set work2. And we're going to input initials, a date of birth that's a string variable, a date of diagnosis that's a string variable, a date of treatment that's a string variable, and a date of death that's a string variable. And so if we're inputting dates as a character string, remember they're no longer numeric values. So let's take a look at what this data looks like. So here you see these are these dates like 01/23/1962, but these are not actually SAS dates. They're character strings. Well, as the comment says, the dates are goofy. How do I fix them? So how do we convert these dates into actual SAS dates? So what we are going to do is we're going to create a data set called fixed dates. And we're going to bring in our temporary SAS data set work 2. And we're going to start by saying if date of birth not equal to missing, then do. So we are only going to fix date of birth if it's not equal to missing. So we're doing a bunch of statements between this do and end statement. First of all, we're setting the length of these variables to 8, which is the default length that you set numeric variables to. And then we're saying MO, which stands for month, equals the input of the substring of date of birth 1, 2. So we're taking off the first 2 digits and making this a month, which is a number. And then we're creating a variable called DA for day, and we're taking off the 3rd and 4th digits and making it a number. And finally, we're creating a variable called year, and we're starting at the 5th position and taking off 4 digits and making that a numeric value, YR, which stands for year. Now, if month equals 99, we're just going to set month equal to 6. So we're going to impute for people who are missing their month that their birth month was month 6. If day equals 99, then we're going to say DA equals 15. So if a subject was missing their actual day of birth, we're going to assume it's 15. If year equals 9999, we're setting date of birth equal to missing because we don't have any idea when that subject was born. Else, date of birth, which is our new variable, equals MDY month, day, year. So we're using that wonderful MDY function to create a date. And then we're formatting date of birth with the MMDDYY10 dot format. And we're going to drop these individual 3 variables. So let's see what happens when we fix just date of birth. So you see here is date of birth looking like a string. And we have now converted it into a SAS date. So it's the numeric value relative to January 1st, 1960. So these are now numbers that we can use in mathematical operations. We could not have used this variable DOB in mathematical operations. So what does this all have to do with macro programming? Well, we are going to create a macro that we can use to repair all of these dates. So we're going to start by saying %macro, and we're calling it date fixer. And there are 2 macro parameters in it. In, which is going to stand for the data string you want to fix, and out, which is going to stand for the name of the new correct date value. And notice here that instead of actually using DOB, we're going to substitute in our macro parameters. So here we're saying if ampersand in, which is the original date string, and then it looks very much like the code above, not equal to blank, then do. And notice that instead of having our new variable that we were creating date of birth, as we did above here, where we had date of birth, in our code now, we're using the macro parameter ampersand out. So basically, we are just substituting in these macro parameters into the code that we saw up above. And interestingly, we are dropping the character string along with the variables day, month, and year. So we're not even going to keep that character string on our new data set. So how are we going to use this macro? we're creating a data set called temp work 2. We're bringing in the data set work 2, which was the data set where the dates were character strings. And then we are going to invoke our macros to correct each of these dates: date of birth, date of diagnosis, date of treatment, and date of death. So you can actually invoke the macro right within the data step. And every time the macro is invoked, it takes the old date string, creates a new date, and drops the old date string from the data set. So let's run all of this code and do a proc print and see what our data set temp work 2 looks like. And here you see we have all the dates that have been corrected, and that's all that's on our data set. So we now just have date of birth, date of diagnosis, date of treatment, and date of death. And these are now SAS dates. And we could do a proc contents of this data set. And let's do a proc contents and see what this looks like. And so here are proc contents. We see that this data set consists of 4 different dates. Notice they're all numeric and they have the format MMDDYY 10 dot. So we have used a macro to fix all of these dates instead of having to repeat all this code over and over again to fix these 4 dates. So again, imagine if you had a data set with multiple dates that had been entered as character strings. Using a macro saves on a lot of code. It can be very, very efficient. You define the macro at one point in your program, and then you can use it repeatedly for a particular analysis that needs to be done over and over again. This concludes the SAS demonstration, Macro Demo 1.